All right, so 9.2, number 33. We want to show one of these trig identities. And so here's what I have. I have sine of x cosine of y plus cosine of x sine of y over, hold your waiting, over cosine of x cosine of y minus sine of x sine of y. And supposedly this is equal to tangent of x plus tangent of x plus tangent of y over 1 minus tangent of x tangent y.
This is a proof problem.
Weird.
That's why you put the question mark.
What's that?
It's a proof problem. That's why
Yeah.
you put the question mark.
Yeah, so Adam suggested that I do this to kind of highlight. Like, this is just thinking stuff for the moment, right? So I'm just gonna like play with this thing for a second and see if I can make this make sense to me. And then I'm gonna write down a nice reason why. You guys with that? Okay, so what do I notice that I might have use for?
Isn't the top and bottom the sum of angles for sine and cosine?
Yeah, that seems legit. So this top thing, that looks like sine x cosine y plus cosine x sine y, right? That's the sum of angles for
Sine.
sine. So I'm noticing that's sine of x plus y, I think. You guys with me on that? What's the bottom?
Sum of angles for cosine.
That looks like sum of angles for cosine, right? So that's cosine of x plus y. You guys see that? Okay, so I got sine of x plus y over cosine of x plus y, which is
Tangent of x plus y.
tangent of x plus y. Okay, so if I knew what the sum of angles identity for tangent looked like,
Oh,
right, I could probably notice that it was that stuff. But I'm not really sure of that, right? Like, I didn't probably give you guys the sum of angles identity for tangent, did I?
do the Google function.
Yeah, don't do that. Don't just look up the answer in the back. That's not any fun.
It's not. I was suggesting.
Okay, so, So I think probably that what we have here is some version of the tangent sum of angles identity. So what else can I do? Oh, that's a great idea. I could like walk over to the other side and like see if I could start from that end. You guys kind of see that? Okay, so let's start from this end. So this end has sine of x over cosine of x, right? Plus sine of y over cosine y. Okay. All over 1 minus, how about sine x sine y over cosine x cosine y?
Jesus.
What a frickin' math, eh?
You could also turn that 1 into in sine cosines too if you really wanted to.
Okay,
You
so,
don't, no.
no, I think I might want to.
No.
So what's 1 in terms of cosine x cosine y's? Like-
Cosine x, cosine y, cosine x, cosine y.
Okay, so it's cosine x cosine y over cosine x cosine y, right? I'm just finding a common bottom. slap a common bottom on the top here. So what's this guy need?
Yeah.
First one needs a cosine y, top and bottom. This guy needs a cosine x, top and bottom. Okay, so I got, ooh, you guys see it? So this crap up here, right? All that shit there. That's
The same thing.
yeah, that's this crap. That's the sum of angles identity for sine. And this crap right here, that's the sum of angles identity for cosine. And then what's going to happen to the common bottoms? Yeah, you're going to flip them over onesie them, right? You guys see that? So that tells me how to get from, I guess, this end to that end.
So you can technically just use that. You only need one way, right?
Yeah, you only need one direction as long as it's all equality, right? Okay, so let's start there. So this was thinking, right? Okay, so now I want to reason. So I'm going to start with something like consider, like tangent x plus tangent y over 1 minus tangent x tangent y. Right? And then what are we going to do with this? So what did we discover? What was our first step?
Turn everything into sine and cosine.
Okay, so we're going to use the fact that tangent of stuff is sine of stuff over cosine of stuff. Right? Okay, so we're going to rewrite. We'll get sine x over cosine x plus sine y over tangent y divided by, oh, thank you. Whoa. How about sine x over cosine x plus sine y over cosine y? And then I got 1 minus sine x sine y over cosine x cosine y. Okay? And then we do something like, what's the justification for this next step going to be? What am I going to do? Yeah, really common bottoms, right? And what Gabe says about 1 is cosine x cosine y over cosine x cosine y is exactly right. So I'm just going to slap all that common bottom stuff in here right away because I did it over here, so I know what the answer is going to be. So I got sine x with a cosine y plus sine y with a cosine x, and that's all going to be over the top of cosine x cosine y. And then all of that's over all of cosine x cosine y minus sine x sine y all over cosine x cosine y. And now I'm erasing my thinking stuff because I don't need it, right? I'm pretty sure I can see the end from here. So then what's this next bit? What do I need to do there? Yeah. Multiply by recip of bottom. So I got cosine y sine x plus sine y cosine x. Oh crap, I'm running out of room. Over cosine x cosine y times cosine x cosine y over cosine x cosine y minus sine x sine y. Next step. Yeah, 1z, or simplify. So then we got cosine y sine x plus sine y cosine x all over cosine x cosine y, oops, cosine y minus sine x sine y. And done. So what do I circle?
The whole thing.
Yeah, all the everything. So the thing I need to circle is this whole answer thought. Cool. And the important thing there is not so much the,
So that
I mean, the algebra is sort of important here, but more important than delineating each step algebraically is delineating what the heck you were doing at each stage. And these arrows are the absolute frickin' minimum you can get by with. So if you go read someone who's, or if you go take a math class from someone who's more like structured than I am, these arrows will have whole little paragraphs attached to them with the reason why. And they might expect that each step include more algebra. Like I'm getting away with writing 1z here because you all know what I mean. Cool? Questions, Steele?